Okay, question 3. It's strictly differentiation. There's 3.1 and 3.2. 3.1, it's the first principle. We are finding a derivative through the first principle. And then 3.2, it's our differentiation rules. All right, let's tackle this question. In the description box, I'll also leave our links for other recordings for this November paper, 2023. Let's see. So lapha ku 3.1, they've given us an equation f of x that is equal to 2x cubed. Determine the derivative of f of x by using first principles. Okay, so if ngithi kuwe find the first derivative of f of x without using a first principle, what answer are you gonna get? You should get to f prime of x equal to, we're gonna apply or use the power rule. Right? We're gonna take the 3 and multiply it by 2, gives us a 6. X and then 3 minus 1, that's 2. So I'm doing this first so that let's apply the first principle. We know what answer we should be getting. Ne? So also now when I a derivative through the first principle, just practice this thing as well, right? So the first principle, it's easy marks. No wrong answers. No wrong answers. You shouldn't get this wrong. Okay, so with 3.1, this is the first principle. f prime of x, the derivative, it's the limit of h approaching 0. Then you have f of x plus h minus f of x divided by h. All right, divided by h. So we do have f of x. We also gonna substitute h towards the end of our calculation, but we don't have f of x plus h. So this is the first thing we're gonna calculate. So I'm gonna say f of x plus h is equal to 2 open bracket x plus h cubed, right? So you basically take f of x, and where there's x you substitute x plus h, then you simplify with the 2 open bracket, I'm a bracket out 3 la. I'm a bracket I 3, then you're gonna FOIL the first 2. Kuzoba x squared plus 2xh plus h squared, then go about h plus x plus h, and then we multiply x times x squared, it's x cubed, plus 2x squared h plus xh squared, then we multiply on h over no h over no x squared h, then over no 2, then over no 2xh plus an h cubed. Let's see what there aren't any like terms now. X cubed, this is a like term. I don't see any other like term. So let's check. When times when, yes. When times when gives this, yes. When times when, yes. And then when times when, where is this one? Where is this one? Okay, one more time. Let me run it. Let me just run it one more time. I think I'm leaving out something. Let's do this. Alright, so x times this indicates this, le times le indicates this, lena times le indicates this times this, it should give me an x squared h. This times this, it should give me a 2xh squared, and then this times this should give me a cube. Okay, let's tell my like terms. Okay, this and this are my like terms. So they are giving me 3x squared h this and this, I'm also getting a 3xh squared and then plus h cubed. Then we're gonna have to multiply by 2 inside, so we got 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed. So this is my f of x plus h. It should be 4 terms. Yes. Yeah, okay. Then we go back to this formula. Then city f prime of x equal to the limit of h approaching 0, 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 2x cubed over h. Then it seems like this one, you cancel another one, equal to the limit of h approaching 0. We are now left with what? 6x squared h plus 6xh squared plus 2h cubed over h equal to the limit of h approaches 0. You take out 2h as a common factor plus 6x h uphumile akasekho la, then la ngoba by 2 kusala 6x h plus 2h squared divided by h, then labo h bar cancelana. So after labo h bar cancelana, so after this cancellation you can now substitute to h again. 6x squared plus 6xh plus 2h squared. Now we substitute again. City 6x squared plus 6x, where there's h in fagu 0, 2 0 squared. The answer was 6x squared. This is my final answer. This one was 0. This one was 0. Remember when we found its derivative here, this is what we had. Alright, so this is our final answer again. This is our final answer. Alright, so 3.2, we have to use the differentiation rules to determine the derivatives of the following, leaving the answer with positive exponents and in sad form where applicable. Alright, so Sizalagu 3.2.1. We are given this function 4 over 5 x raised to exponent 5 plus x over 2 plus e raised to exponent 4 plus cos 30 degrees or cos 30 degrees. All right, how many marks? 2 marks. All right, back lana, it's gonna be, we're gonna use a power ruler, then we're gonna apply the exponential law, right? And then lana, this is a constant. Cos 30 degrees, it's what, conj? Cos 30, it's square root 3 over 2 plus la, nothing changes. All right, it's a good thing if your x is a numerator, but if your x were a denominator, you would have to put it on the side. But I like dealing it, or I like saying, make sure that before you differentiate, your x is sitting on the side, so x wakho ngumbeka la, so x wami usuka phezulu, I'm putting it on the side. I'm not changing the exponent. But if the case were maybe 2 over x, then you would simplify this to a 2x raised to exponent minus 1. If x usuka ngaphansi, you make the exponent to be negative. But if the x comes from the top, you keep the exponent as positive, right? So 4 over 5x raised to exponent 5. So lana, nothing to simplify. The x is on the side, right? Now you can get your first derivative. So dy dx is equal to, use differentiation to determine the derivatives. So yeah, we are looking for the first derivative now. So dy over dx is equal to, we take this 5 and multiply 4 over 5. What are we getting? We get to 4 x, then 5 minus 1, that's 4. And then on this instance, so tata this 1, see times the ubani, half, see we no half la, and then 1 minus 1, that's 0. Meaning that 0 now, I mean x now raised to exponent 0, I'm getting a 1. Plus, lana, it's gonna be an e raised to exponent 4. So now differentiator e raised to an exponent, it doesn't change, right? But we also apply in a chain rule, right? Meaning that we also have to grab the exponent and differentiate it, right? So for functions like apu sine, cos, tan, even the exponential function as well, also differentiate out those three functions or those functions, you need to make sure that you also take what's raised as an exponent or what is inside the bracket in the case of our trigonometric functions and differentiate it as well. So the derivative for this as a whole stays the same. Then taking the exponent and differentiating it, what is the derivative of 4x? It's just 4. So you also need to put 4 next to the e, plus 0. So this is the final answer. This is the final answer. All right, 3.2.2. 3.2.2. This is the given function 3 ln, okay, yes, it is ln, but sibala as ln 5x minus 3 sine 5x minus 2 over x exponent 5 plus with 3 raised to exponent x. So this is what I kept on saying, Guti. This is a function, a ln function. So we differentiate as a whole. After differentiating it as a whole, you also differentiate the function inside. You differentiate this as a whole and differentiate what is inside the function. That's what I was explaining above. So lana, before we can even start with the differentiation process yet, we need to simplify this because x is a denominator. We need to simplify this because we have a side. Minus 3 sine 5x. Do not differentiate until everything is in order. We're not differentiate this and this and then you simplify a log, then you differentiate again. No, don't do that. Don't do that. Fix everything up first and then you can differentiate afterwards. So it's minus 5 now. Then lana it's gonna be 3x exponent 1 over 2. Now we can differentiate. Dy over dx is equal to 3 multiplied by, but don't worry, you should have onke lama derivatives now at the back of your question paper. So what we are looking at much point number 11. Point number 11, we are given a function of ln kx. So finding the derivative for that, we're just gonna say k over kx, right? So that is why minangiti where am I writing? Yeah, okay. So that is why it's this 3. Yeah, drop a then I'm multiplying with the derivative of this. So the derivative for this, it's actually 5, which by the way it's this k over 5x over 5x. So it's this k, which is that 5, over kx, which is this 5x, minus 3. What is the derivative of sine? Sine derivative yakhona it's cos x, so it's gonna be a cos 5x la, multiplied by u5, the derivative of the 5x, and then lana it's the power rule, so this one it's this power rule. So tata this, we multiply with that, you get a positive 10x, and then you minus by 1 lapha uthola ngayikho minus 6. Then uthatha this half, we multiply with 3, you get a 3 over 2x raised to exponent bani minus half. Now the half minus 1, total minus half. Now let's simplify this further again. The 5 will cancel 5, sala 3 over x minus this 5 it times that 3, you see power 15 cos 5x. Then it's a plus 10 over x to exponent 6, but you leave your answer with positive exponents and insert form where applicable, right? So this should be simplified to this, right? That the negative exponents is simplified to this, and then lana it's gonna be a plus 3 over 2 square root of x. This is our final answer again. This is our final answer. Now for the last question, for the last question, 3.22 equal to 1 over 2x cubed minus 4 close bracket raised to exponent 4. Treat this whole thing as a function on its own. This thing as having a function. I mean the 1 over 2x cubed minus 4 raised to exponent 4. Treat it as a function. Bigger as a whole, it is a function. And then what's inside the bracket, it's another function, right? So lana, it's strictly chain rule. You're gonna use the chain rule. So the chain rule, you use it whenever there's a function within another function. So this is a whole, it's a function. Inside that function there's also another function, so we are dealing with the chain rule. Hence I'm saying nala, apply chain rule. Nala, apply chain rule. This is based off these principles, right? So you take the derivative for the whole function, then you take the derivative of the smaller yana function inside. So this, we're gonna say y is equal to 2x cubed minus 4 close bracket raised to exponent minus 4 because if x we denominator, or if that bracket is a denominator, I cannot find the derivative. I cannot find the derivative. So we're gonna say dy over dx is equal to, apply power rule, you take this, you multiply the one in front, you now have minus 4 open bracket 2x cubed minus 4 multiplied by the derivative of what's inside the bracket. What is the derivative of 2x cubed minus 4? It's 3 minus 2, 6x raised to exponent 2. Then the derivative of 4, it's just 0. So I'm just going to close the bracket. Then I'm going to multiply this with that. I'm getting a minus 24 open bracket 2x cubed minus 4. Okay, there's something I forgot to do now. Now remember, we took this, multiplied that, Satola this. I forgot to say minus 4 minus 1 should be a minus 5 right? Then we continue, it's a minus 5 lana, so the final answer is gonna be a minus 24 over 2x cubed minus 4 close bracket raised to exponent 5. So this is the final answer. You can also use the substitution method. Let me do this. Nope. Yeah, it's this one. You can use the substitution method. Where is it? It's demonstrated somewhere ku formula sheet yakho. Yeah? So I'm gonna end the recording here. So now what you have to do, just as an activity for you to do, try solving 3.2.3 using the substitution method and see if you're not getting the same answer as this one. The answer wrong. This multiplied by that, it's minus 24. Yes, it's minus 24, but short to x squared la. There's a missing x squared la. So it's actually minus 4. I'm erasing the wrong place as well. Okay, so life should be a minus 24x squared. Yeah, so this is the final answer again. Minus 24x squared. So this is the final answer. So try using the substitution method and see if you don't get the same answer as mine. So for now, guys, I'm signing out. See you on the next one. Peace.